All right, well, so for multiple linear regression in a spreadsheet, suppose we have five predictors. So I have A through E here as predictors, and then a response in column F. Well, this works just like it did before the linear estimation command, in that I just need to highlight, and I need 5 rows. And what I have to highlight is enough room for all my predictors plus the intercept. And so I labeled it ahead of time, and notice I have them in reverse order. So it was predictor 1, 2, 3, 4, 5. Here it goes predictor 5, 4, 3, 2, 1. And that's because the output puts them out in reverse order. And then there's the intercept. And I have my 5 rows that are needed. So I highlight that and then start typing. Here's my line est command, or linear estimation command. The first thing that goes in there is your response variable, then a comma. Now I just grab and highlight everything there for the predictor. So if you look down at the bottom, it says 30 rows by 5 columns, and then comma, and finish it up with a 1, comma 1 again, and close parentheses. Control Shift, hold those both down, hit enter, and it fills everything in. It's a vector command again. And so we get our degrees of freedom of 24. So that was our 30 rows, minus 1 and minus the number of predictors. So we got our 24 there, and our coefficients. So again, these are in reverse order. And if I really quickly get the ratio of the coefficient with the standard error, so equals, and I'll use absolute value of the coefficient, or the slope, right up there in H2 in this case. Take that absolute value, divide that by the standard error, hit enter, and I see in that case I get a very small number. If I grab this and fill it over for a copy and paste, what I notice is that predictor 5 and predictor 2 do not seem to be significant. They have low ratios, smaller than 2 or 2.5. And so if I were to do a t-test on those, I would get a big p-value, bigger than 0.05. But these, predictor 4, predictor 3, predictor 1, are all very large values, much bigger than 2 or 2.5. So I know they would have very small p-values. So probably I don't want to keep predictor 5 nor predictor 2 in my model, looking at this. And so what I would do further is reduce this down. So here I went to a second sheet where I just have predictors 1. Let me get rid of that, and I'll add that in again. Predictors 1, 3, and 4 with the responses. And so I would run this again. 1, 2, 3, 4, 5, have them all there. Again, notice I have them in reverse order. I type in my spreadsheet command, linest or linest, linear estimation. There's my response. Now in this case I only have 3 columns for predictors. Put those in, and then my 1, comma 1, close that and hold down Control Shift, hit enter, and there we see, and it looks like my slope here for predictor 4 is about a 3. for predictor 3 is about a -4, and predictor 1 is about a 2. And notice the intercept looks like it's probably 0. That was the case on the previous one. And so if I had to write a formula, it looks to me it would be something like, if I use x1 for predictor 1 and so forth, it'd be something like y equals, and I'm just rounding here, so I'm going to say 2x1, like that. Maybe I should show a asterisk here, x1, because the typesetting's not so great, minus 4x times x3, and then about a 3, 2.936. We'll just call it 3 plus 3 times x4, and then no intercept. I won't add an intercept because that doesn't look to be significant. And so there's my model, y equal 2x1 minus 4x3 plus 3x4, and that's the basics of the multiple linear regression running that command. In the next video, we'll look at the adjusted R squared.